At Autodesk's robotics lab in San Francisco, UR robots are used in research projects, exploring new ways to automate the construction industry. The projects span human-robot interactions, machine learning, drawing, and smart assembly systems.
The inspiration for the Hive project was really thinking about the way people talk about the future of robotics. And there's always these sort of apocalyptic robots are going to take over and humans will have nothing to do. And we wanted to explore the possibility of humans and robots working together to accomplish things that neither species could accomplish alone. They used an Apple Watch to control their robot. There were lights and location-aware sensors. We had each human and robot working together to create a building piece that would be part of a larger structure. The big reason we chose to use the universal robots was because of the human safety and collaborative element. If we had wanted to use a larger, more industrial robot, we wouldn't have been able to engage with the public in the same way, and it would have been a much slower research project. But with the universal robot, we were able to be a little more daring with our research because we could trust that the robot wouldn't break itself and wouldn't pose a danger to others. We used raw bamboo, which is a very uneven material. A big question for this whole project was, is it possible to give a robot this irregular piece, which I think is really relevant, particularly to construction. In manufacturing, the supply chain can allow for much smaller tolerances, but in construction, the tolerances are pretty broad. And so one thing we really weren't sure of and we were really proud of was our ability to empower the robot by giving it sensors and decision-making abilities so that it knew enough about what it was receiving that it was able to ask sensors for more information about the specifics of that piece of bamboo, and then was able to act on that accordingly. We found the URs to be much easier to stream information to than some of our larger, more industrial robots. The scripting language for the UR is also very simple to learn and to use.
I made a fun little short film called R2 in Love, where we wanted to explore sort of advanced robotics, more intuitive robotic control, human-robot interaction. There's a sort of falling in love montage in the film, and you always see people getting their caricatures drawn. So I thought, wouldn't it be awesome if we had a robot drawing a caricature of this robot with his love interest? And we had just gotten the UR10, and that seemed perfect. It was small, it was mobile, it was safe. One of the things we've often thought about is robots on the construction site. And for a big industrial robot, it's not super feasible, but we started a demo project where we put a router on the end of the robot, gave it a camera and a projector, and we could just push it up to a piece of drywall and just say, cut an outlet there. You'd be able to point. It would see where you point. It would project the outlet so you could confirm. Then you say, all right, cut. And then it would go and cut that outlet. You could put it on a little cart and just roll the cart around and then have the robot help you out around the construction site.
So what we're trying to do here is use machine learning with the universal robots to really explore the potential of creating smart robotic assembly systems. Today, they tend to be kind of hard-coded when things become misaligned, or the parts that are in that assembly need to be swapped out. So the design itself needs to be changed. The whole line becomes out of sorts. So what we're trying to do with this LegoBot project is really try and create a more robust assembly system, something that's smart, something that's flexible to change, easy to set up, and readily accessible for our customers so that they can take their designs and automatically have some system put it together so that they can realize the final product. We're starting with Lego right now. It's very tight tolerances, and there's something like 10,000 plus different bricks out there, so you can do some pretty complex assembly scenarios. The next iteration, we hope to start design, say, a house, and then have the system automatically built. The reason why we're choosing the universal robots is a couple reasons. So one, it's an industrial grade robot. The other reason would be the API. They're very open and accessible. We're able to get pretty low level and controlling the UR robots, which was very vital for our needs. But also for us, it was really nice that it's human safe. I could actually literally connect the robot to my laptop and work next to it and quickly iterate through our experiments, which was, I think, very important for us to make progress in this particular project.